Okay, guys, so we're looking right now at this Desmos, which I provided a link for. We're looking at variations on sine and cosine. Sine or cosine pretty much is identical, pretty much the same thing as we've seen all along. Okay, um, so you have the four controls. A, which is going to control the amplitude, as you could see here. Okay, increase the amplitude, flip it over the axis when it's negative. Okay, um, the B value, which is going to control the period, how many waves you get. Okay, so I want twice as many waves here. Trade-off is half as many, the wavelength is half its usual. Okay, um, so the period is 2 pi, the normal period divided by the B value. One other thing that's pretty obvious is this D value, which is going to control the vertical displacement. And of course, controlling the vertical displacement will also offset your range. So bear that in mind. Now, one factor which we have yet to look at is what this C factor is. Okay. So the C factor is going to impose what we call a phase shift, So, which is a horizontal translation, right? So when C is positive, the graph will move to the left, as you can see here. Okay. In fact, what did I do? I move, okay, I have invoked a value of pi over 2, that's 1.57 as C. And what has it done? It's taken my graph and it's shifted my sine graph, okay, pi over 2 radians to the left, okay, with the plus, it's a shift to the left. And as you can see, that is, in fact, and if I downsize my amplitude, I've got the graph of the cosine, okay? So we say that the sine or cosine are just a phase shift of pi over 2 radians away. So we want to look a little bit more definitively as to how we invoke that phase shift, because when we have the 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 C value in conjunction with the B value, we have to look at their ratio to determine the phase shift. Okay, so uh, let's keep that in mind as we go through the presentation on the slideshow. So we come to that in just a sec. So here we are looking at this PowerPoint presentation, and we're going to look at a function where we have the A, B, and C being controlled here. Okay, so the A, B, and C are in place. So we're going to tell you by definition the phase shift, that is shifting the graph left to right, is controlled by the value of C over B. Okay, phase shifts are the same as horizontal translations. Okay, so if the phase shift is positive, it means it's shifting to the left. If the phase shift is negative, it means it's shifting to the right. So here we're looking at this function, okay? Identify A, B, and C. A is not going to have any bearing on the shift. Both B and C are going to have bearings. Since the B value is 1, and we say that the phase shift is C over B, it's simply pi over 2 over 1, which is pi over 2. Since this says plus, it means it's moving in the negative direction. So we have a phase shift of pi over 2 units to the left, okay? So for purposes of our constructing the graph, rather than construct the graph at the origin, we're moving it back pi over 2 units, okay? Pi over 2 units. Now, the period is still 2 pi, so if we start at negative pi over 2, then we should be ending at 2 pi later at 3 pi over 2. So here's our graph, okay? We start at negative pi over 2 because the graph's been pulled back. We're moving a full wavelength of 2 pi, which is going to end us up at 3 pi over 2, okay? So then we find our halfway mark between negative pi over 2 and 3 pi over 2 is positive pi over 2. Our halfway mark between pi over 2 and negative pi over 2 is right there uh, at the um, at the origin, okay? And our quarter way mark here is at pi. So we're doing the sign which crosses the beginning, middle, and end. So we will cross at where we have the dots, okay? And we put our graph in, and it's pretty much a done deal, okay? So here's our graph. And of course, we accounted for an amplitude of 2. We just have to mark that off on the y-axis, okay? So it's the same graph. It's been shifted back, okay? The fact that you're shifting it back will impose that the intercepts will be at different locations, but still we are finding our intercepts at the beginning, middle, and end, just like we did all the way through, okay? So now let's look at the cosine graph, all right? So here's the uh, graph that we want to plot. 3, the cosine of 1/2 x plus pi over 4. So it's a cosine graph, guaranteed to look like what's here in yellow. Okay. The biggie is getting getting the axes in. That's where that's where you have to take your time. Okay. But the graph is, this is any cosine graph. All right. So the positioning is going to be determined. So we find our period, normal way, 2 pi divided by the b value. 2 pi divided by a half is 4 pi. So our span is twice as much. The phase shift is c over b. C over b. Can't forget that. C over b. So that's pi over 4 over 1/2. Pi over 4, okay, divided by 1/2 is pi over 4 times 2, which gives us a phase shift of pi over 2. Pi over 2, just like the phase shift we saw in the previous graph. Okay, that phase shift is pi over 2 to the left. Okay, so we're moving it to the left because it's opposite the sign that's represented here. And again, we're going to start at negative pi over 2 with a cosine graph, and we're going to span, okay, a total of 4 pi. So one way of looking at it is 4 pi divides evenly in quarters at pi lengths. Okay, so when I'm putting my axes together, okay, I could go one of two ways. I could just say, well, every quarter wavelength is a spanning of a pi. So if I'm starting back here at negative pi over 2, a quarter wavelength will end up pi units later at pi over 2. Another quarter wavelength would expand to a value of pi. So that would step me up to 3 pi over 2. Okay. And then we are up to 5 pi over 2. And then lastly, we're up to 7 pi over 2. So the span from negative pi over 2 to pi over 2 is a span of 8 pi over 2, which is, of course, 4 pi, which is what my period is said to be. Again, my cosine graph is crossing at the quarter and 3/4 way marks on the along the period at the quarter and the 3/4 way mark, and I've indicated my amplitude is at 3, so I'm reaching my high points at the beginning and end of my cycle, and reaching my low point midway through the cycle, as is always characteristic of the cosine graph. Again, the cosine graph characteristic, okay, to think about. High points are always at the beginning and at the end, okay? Unless, of course, it's flipped, in which case there'll be the low points. And the low points always halfway through, okay? Then the intercepts are a quarter of the way in from either end, or at the quarter wavelength and the 3/4 wavelength. Remember those. You should be able to graph any kind of sine or cosine function with any of these 4 variations, okay? Lastly, if we were going to do a vertical translation, then I would get this in place. I would get this in place. Then if this had said perhaps +2 at the end, I would just shift everything up 2 units. Or you could just pull the axes down 2 units, okay? So that's what we do for graphing with phase shifts. Remember, the phase shift is the C over B term. So, and the phase shift is in the opposite direction indicated by the sign, okay? So figure out the period, the phase shift, okay? Move the phase shift left or right and use that as your starting point, okay? And then span one whole wavelength, find your ending point. Okay, so we had a phase shift of pi over 2. We knew our wavelength was 4 pi, so 4 pi added to negative pi over 2 ends up at 7 pi over 2. We can find that's halfway point, and then the halfway point between 3 pi over 2 and 7 pi over 2, 5 pi over 2, and the halfway point between negative pi over 2 and 3 pi over 2. Okay, so that's it, and that's what we do with phase shifts on sines and cosines.